We will be starting with the topic. So all of you just see what is the objective of today's lecture is to learn or to study about the components that are used in fiber optics. Okay, so we had seen couplers, that was a component. Okay, so similarly continuing with those components, we have isolators, we have circulators, we have multiplexers, which includes demultiplexer as well. Then we have filters. Then one special kind of phenomena, or you can say a device, which is called as fiber grating. Okay, now this fiber grating, I don't know whether you people remember or not. When we studied measurement of attenuation, we had a monochromator. Okay, so the monochromator I had mentioned, we had a prism or a grating kind of material. Okay, so that grating we will be studying in detail. And then the Fabry-Perret filter. Okay, so there are certain principles. So totally a theoretical topic. Okay, short notes will be asked directly. Okay, so the learning outcomes is you will be able to explain the characteristic and the working principle of various fiber components. And when you actually design a fiber optic system, you require a multiplexer, you require a demultiplexer, you need to filter out certain signal, you have to place isolators, circulators if you want to send the signal to multiple paths. Okay, without reflecting back to the source, I require a circulator. So we need to understand that. So we just study about this component. We are not going to use that component ahead. Now, before I actually start with the isolators and circulator, have you heard about polarizers? At some point of time, have you heard about the word polarizer? Yes, anybody? Polarizer? You have not heard about what is a polarizer?
Polarized glasses are cool. No?
Yes, polarized glasses. What they do? Any idea?
It decreases the glare.
Wait,
The
I'll show
glare
you a video.
If
Just see whether you can understand what we are doing in a polarizer. Just give me a minute. This is an animated video I'm going to show. Just have a look and then you can tell me what is polarizer and why we require it in fiber optics. So that this is a prerequisite which I am showing you, because that word will come often when we are discussing about isolator and circulator. So just have a look at the video.
With free education for life, book a free coding class with White Hat Junior.
Was it clear a little bit?
Films with high precision and accuracy. To understand how ellipsometry works, we must start.
Yes. So, was it clear a little bit? What was that polarizer doing? Yes.
Separating light waves.
Separating out light wave. Yes. So we had, you can see there was the light signal. So various kinds of waves at different frequency, or you can say wavelength, was emitted. And the polarizer, that filter kind, they had mentioned it as a filter. It had a certain, as a vertical slots thing. Okay. So what it did was it blocked the other wavelength of light, and it allowed only that wavelength which was passing actually horizontally. Okay, and that wavelength of light was allowed to pass through it. So that's why that polarizer acted as a filter. Now polarize, why I'm using that word polarization, polar q use करते, because that wavelength was having that kind of polarization. Might be you call it horizontally polarized, or in some case it might be vertically polarized. So based on your orientation of polarization, the waves were allowed to travel further. Okay, so that is what was your polarizer, and we required it as a prerequisite. Now, how we are using this polarizer in our concept, we will see later on. Now, what we are going to study is isolators and circulators. So when I talk about isolators, please note down the keywords, because I might take a quiz, not today, might be later on. So we had studied couplers. Okay, so what are couplers? Couplers are passive optical devices, and they are reciprocal devices. In that, what happens is the device works exactly the same way if their inputs and outputs are reversed. Like you have a coupler, one incoming signal is sent into the remaining ports. Now it might happen that the incoming signal might be from port 3, still it is coupled to the remaining port 1, 4, and so on, depends upon what ports we have. Okay, so that is, it is called as a reciprocal device. Means if I change input as output and output as input, the functioning remains the same. Okay, however, we require some device which is passive non-reciprocal. Like we don't want a reciprocal device. Okay, I don't want my input to behave as an output. I want my input to be as working as an input only. Okay, so isolator is a device. So you can say couplers are reciprocal device, isolators are passive. See, this passive word I'm using means I don't require a separate method or means to charge that or power up that आइसोलेटर और अ कपलर. अगर मुझे कपलर इंसर्ट करना है तो मुझे वो कपलर के लिए बैटरी बैकअप नहीं चाहिए. नो, सो इट्स अ पैसिव डिवाइस. आई विल सिंपली कनेक्ट इट इन द फाइबर स्ट्रीम. Okay, and then the function of coupler and isolator will happen. So please mark this thing. So couplers and isolator both are passive device. Coupler is a reciprocal device. Again repeating, reciprocal means I can change the input and output terminal. And isolator is a non-reciprocal device, means whichever is input, that has to be the input. Okay, now continuing with isolator. So what is isolator? If I tell you to define isolator, so I'm not asking you, the definition is already there. So isolator's function is to allow transmission in one direction, but it blocks the transmission in other direction. Okay, so it is isolating, so it is blocking the transmission. Okay, so if I don't want the transmission in a particular direction and I want it only in a certain direction, then I will use a device which is called as isolators. Now where do I use isolators? This is important. Isolators are used in the system at the output of optical amplifiers and at the laser. Okay, so in my fiber optics system, where do I place the isolator? So if you are going later on into the field of telecommunication, geo, all these placements are going on. And if you are in the designing team or in the field and you need to locate an isolator where an isolator is there, so at the output of optical amplifier, why? Because at the output of optical amplifier, my signal is already amplified. It is having high power. So I don't want it might be to go back, okay, towards the source. So I require an isolator so that the signal goes ahead. Similarly, case of laser, I want high directional signal. Okay, so high directive signal. So I will place it after my source immediately so that laser is my source, so that the signal does not go back to the laser and damage the source, but it should go ahead. So I will place it after optical amplifier and laser to prevent reflection from entering these devices. I need to protect these devices. That is my optical amplifier and the laser. Okay, so not only protection, it will also degrade the performance. Okay, so these are the two reasons why I need to use an isolator after the optical amplifier and a laser. Okay, now when I talk about isolator, which are the two key parameters that are important in case of isolator is the two parameters are called as insertion loss and the second one is called as isolation. Okay, now what is insertion loss? It is the loss in the forward direction which should be as small as possible. Okay, so that is my insertion loss, and isolation, it is the loss in the reverse direction which should be as large as possible. Please write it down, all of you, these 2 points. So when I talk about isolators, two parameters are important. It is the insertion loss, which is in the forward direction, and its value should be as small as possible. And next one is isolation. That is, it is the loss in the reverse direction, and it should be as large as possible. Okay, so the typical insertion loss here you can see, since it is small, it is around 1 dB and the isolation is around 40 to 50 dB. Please remember, we are discussing isolator with respect to fiber optics communication. In microwave also you have isolator, circulator, directional coupler, everything. Okay, but whatever we are studying, only the name is same, but the things are totally different because they are dealing with a microwave signal, we are dealing with a light signal. Okay, so these values might not match if you try to compare a microwave signal parameters with an optical signal parameters. So insertion loss around 1 dB because it is small. Isolation loss is around 40 to 50 dB, which is a quite high value. Now come to circulator. Now, circulator is similar to an isolator except that it has multiple ports. Okay, now what happens in an isolator is I have one incoming port, the signal comes, I have an isolator and the signal goes to the outgoing port. Okay, so I need to have only one incoming port and one outgoing port, and the isolator construction is done in such a way that the signal goes out of the output port. There is no way in which the signal from the output port will enter back again towards the input port. So that is, I require only 2 ports in case of an isolator. But suppose I have a circulator. So in a circulator, I might have one incoming port and I might have more outgoing ports. Okay, so it has multiple ports, typically 3 or 4. So here is a diagram of a 3-port circulator. So here you can see an input signal on port 1. So here an input signal on port 1 is sent to port 2. An input signal, suppose it is coming from port 2, is sent out to port 3. And an input signal on port 3 is sent out on port 1. So this way the signal is circulated. I hope you understand what is the, from this diagram, what is the difference between a circulator and a coupler. In a coupler, we have one incoming signal that is sent through the other ports. Some ports might receive high signal, some might receive little, some might be an isolation port, okay, where the signal does not come out. But in case of circulator, we have many incoming signal. Only that the incoming signal from one port is routed to another port. So from port 1, it is circulated, sent through port 2. From port 2, another signal enters and it comes out through port 3. And from port 3, another signal enters, comes out through port 1. Okay, so I have multiple signals entering a circulator and multiple signals coming out of the circulators. Okay, so where do I require a circulator? It is useful to construct an optical add drop element. Okay, circulators also work on the same principle of isolate. I will explain you this principle. So is the concept of circulator and isolator clear? What are the uses of isolator and circulator? Yes? In Viva, probably you will have a Viva. Definitely you will have a Viva. What kind of exam, I don't know. But you should be able to tell all these difference. Okay, so let us understand the principle of operation of isolator. The same principle will hold true for a circulator. So this is important. Okay, so again, remember I had showed you polarizer in the beginning, the video, because that was the prerequisite. So the principle includes the notion, or you can say the idea of polarization. Now, just read some sentence before I actually show you the diagram of the working principle of an isolator. The SOP, that is called as the state of polarization of light propagating in a single mode fiber. So what is the state of polarization? The definition first they are explaining. It refers to the orientation of its electric field vector on a plane that is orthogonal to its direction of propagation. So the electric field vector is orthogonal to the direction of propagation. At any time, the electric field vector can be expressed as a linear combination of two orthogonal linear polarization supported by the fiber. This point we had already discussed when we studied polarization mode dispersion. So a single wave is a combination of two orthogonal linearly polarized signal. Okay, the same concept we are using over here. Now, what we just give it a name, we call these two polarization mode as the horizontal mode and the vertical mode. Since they are orthogonal to each other, we can say one is propagating in the x direction, so I can call it as the horizontal mode. One I can say 90 degrees, so it is moving in the y direction, or you can say it is the vertical polarized mode. Okay, so the state of polarization word we are doing, it is the orientation of the electric field vectors. Electric field vector is always a combination of two modes. They are orthogonal to each other. One of the mode I'm calling it as horizontal mode, and the other mode I'm calling it as the vertical mode. So I expect those who are making a notebook or something, please draw this diagram, because when you read for your theory and all, I don't think you draw and practice. Okay, and see, since the IA is okay, so this is the principle of operation of an isolator that works only for a particular state of polarization. We had seen that there are two states of polarization, that is your horizontal polarization and your vertical polarization. And this isolator will work for only one state of polarization. Means if I signal enters the isolator, okay, so it will allow, you might say, only horizontally polarized wave to come out, or only vertical polarized wave to come out of it. Now, what is my actual working of an isolator? I don't want the signal to go back towards the source. Or you can say I have an incoming port and I have an outgoing port. If by chance there is some reflection from the outgoing port, the signal, if it is reflected, it will reflect. Okay, we have seen signal reflect. That is how we use OTDR, because the signal is reflecting back. So even if the signal is reflecting back, I will have a mechanism in which the reflected signal will be rejected when it tries to go back towards the source. Okay, so that's why we say that it works only for a particular state of polarization. So please draw the way it is drawn, because your all explanation is the way these circles are there. So we have an incoming light. The incoming light is first falling on a polarizer. I have shown you a polarizer, how it works. So that polarizer block, and here you can see the lines, horizontal lines. Okay, so draw it horizontally. Then we have something called as Faraday's rotator. Okay, so this Faraday rotator will give a rotation of 45 degrees. So please mention here Faraday's rotator giving a rotation of 45 degrees. So here you can see the state of polarization is vertically polarized. It is aligned in the y direction. So state of polarization is vertically polarized. The polarizer यहाँ पे देखो vertical lines है. Okay, so means it will allow the signal which is vertically polarized. So अगर horizontally polarized signal आ रहे हैं, that will be rejected by this polarizer. That is, it is acting as a filter. So since I have the signal which is vertically polarized, that signal is allowed to pass. Okay, I'm not bothered about the horizontally polarized signal. So यहाँ पे मेरे पास vertically polarized signal ये isolator के अंदर आ गया. This is the whole thing is my isolator. Okay, inside my isolator. This is the incoming line. Now then that SOP which is vertically polarized, that falls on a Faraday's rotator. Now what is the function of Faraday's rotator? Whichever is the incoming light, it will give a phase shift of 45 degree. Okay, so I have this light, so it is giving me a phase shift of 45 degrees. So यहाँ से ये 45 degree tilt हो गया, from this position to this position, ये 45 degree shift. So that's why this line is this way. Then I have another polarizer. Now you see how the polarizer is drawn. That's why I'm telling you to draw so that you will understand. यहाँ पे ऐसे straight vertical था, horizontally polarized signal. यहाँ पे exactly इसी से parallel है. These are parallel. So 45 degree parallel lines draw किया हुआ है. So this polarizer will allow the signal which is having this 45 degree का angle. Okay. So that signal comes out of the polarizer. Okay, and the journey continues. Now, what happens if suppose the reflected light enters the isolator? It should not allow, bahar aana nahi chahiye yahan pe. Okay, so suppose I have some reflected light. Ye light jo aage gaya hai, it was having a phase shift of 45 degrees. So the incoming light also suppose has a phase shift of 45. So the same signal is now reflected over here. So the polarizer, what it will do, it will allow this light to go ahead. So ये 45 degree वाला जो light है, polarizer also is of 45 degree slope. So it allows this light to enter the isolator. So reflected light has entered the isolator with the help of these polarizer. Now it faces the Faraday's rotator. Now what this Faraday's rotator will do, its work is to give a phase shift of 45 degree to the incoming signal. So now the incoming signal is already having a phase shift of 45 degree. Then this Faraday rotator will again give a phase shift of 45 degrees. So 45, another 45, it gives me 90 degree. I hope you people are understanding this. Okay, so now my phase shift is 90 degrees. So this becomes horizontally polarized now. Now it comes to this polarizer. This polarizer will work only for vertically polarized, or you can say state of polarization is vertically polarized. Now it is horizontally polarized. So what will happen is this signal which has entered the isolator is blocked by this polarizer, and it will not come out from the input port, or it cannot go ahead towards the source. Is this clear, all of you? I'm just whatever sentences I have said, okay, the explanation, the diagram remains the same. Just read it. It is there in my slide. So I just want you to read that explanation. So assume the input light signal has vertical SOP shown in the figure. Okay. It is passed through a polarizer which passes only light energy in the vertical SOP. Okay, and blocks light energy in the horizontal SOP. That is what is explained about this particular polarizer. The polarizer is followed by a Faraday's rotator. A Faraday's rotator is a non-reciprocal device. Okay, made up of, so please remember, a Faraday's rotator is a non-reciprocal device. Those who joined late, I have already explained what is a reciprocal and a non-reciprocal device. Made up of crystal that rotates the SOP, say suppose for example clockwise by 45 degrees, regardless of the direction of propagation. So whatever way the signal strikes the Faraday's rotator, it will give you, suppose for example they have said, a clockwise rotation of 45 degrees. The Faraday's rotator is followed by another polarizer that passes only SOP with the 45-degree orientation. Thus, the light signal from left to right is passed through the device without any loss. On the other hand, the light entering the device from the right, this ray they are talking about, due to reflection with the same 45-degree SOP orientation, is rotated by another 45 degree by the Faraday's rotator. So the total phase shift becomes 90 degree and is thus blocked by the first polarizer. So see, such a simple arrangement they have done. They have just used two polarizer, one Faraday's rotator. So this whole thing is present inside an isolator. Okay, so I will show you this video tomorrow, video of an isolator. I already had it, but I'll show you tomorrow. Coming to multiplexers and filters. Okay, so multiplexers and filters. Why these two topics together? That is also one question. Okay, so now what is optical filters? Optical filters are essential components in transmission for two things. Okay. First, I want to multiplex and demultiplex wavelength. See, in fiber optics, we have wavelength division multiplexing. Okay, so I want to multiplex or demultiplex and multiple wavelength signals. Okay, so the components that do these functions are called as multiplexer and demultiplexer. Now, when I'm sending multiple signals, okay, I need to have equalization of gain and filtering of noise in optical amplifiers. So that's why we are dealing with these two topics together. Okay, multiplexers and filters. Now, what is a filter? If I want to just give a definition in case of fiber optics. So it is just a two-port device that selects one wavelength and rejects all others. So if I say I want a particular wavelength signal, so I simply give it to a filter. Okay, construction wise, you can see it is just a two-port. So it selects only one wavelength and then it rejects other one. Okay, now you might feel, अरे इतने सारे wavelengths थे फालतू में waste हो गए, सिर्फ एक को ही आगे भेजा. Okay, so what we can do is we can construct a filter with a third port also. So what we will do, all those rejected wavelengths, only one is allowed to pass. Okay, so suppose that comes out from the main port. All those rejected wavelengths can be available at the third port. Suppose you want to do something with those rejected wavelengths, okay? So that we can make available at the third port. So that is your simple filter in case of your optical communication. So here you want to draw a diagram. So you can see I have incoming signals lambda 1, lambda 2, lambda 3. So I have a wavelength filter. It allows only one wavelength to come out from the second port. And if you want, see this is by a dotted line because usual convention is मुझे एक ही wavelength का filter चाहिए. But suppose if you want to do something with the remaining wavelength, so you can have a third port constructed and then you can have lambda 2, lambda 3, lambda 4 available. So this is a filter, okay, which is doing that, and it is a wavelength filter. It is sensing only the wavelength. Similarly, I have a wavelength multiplexer. So I have incoming wavelengths over here, and this multiplexer is combining those wavelengths, and a single signal is carrying these multiplexed wavelength signal. So if I want to define a simple filter which selects one wavelength and either blocks the remaining wavelength or makes them available on a third port. Similarly, a multiplexer which combines the multiple wavelengths into a single fiber. In the reverse direction, the same device acts as a demultiplexer to separate the different wavelengths. So I can have a wavelength multiplexer. Reversely, if I operate, it can act as a demultiplexer. Now, before we go further, can you tell me what should be the key characteristic of a filter used in fiber optics? Filters you have been studying since long. Okay. You had from BEE, you had studied RLC series circuit, RLC parallel circuit, resonance. So that was your filter. Then you had high pass filter, low pass filter, simple RC filters as high pass, low pass. Then in LIC you studied filters, DTSP may be filters भर के पढ़ा है. So just I want key characteristic of filters used in fact. Just think about it, everybody, one point. I will take the attendance meanwhile. You have
We
been
should
filters,
be
yes?
able to reject or pass certain frequencies.
Reject or pass frequencies, okay?
Ma'am, it should be sharp in nature.
Sharp in nature.
It should remove noise.
Remove noise. Then yes, Shreyas, anything from your side?
Ma'am, it should allow certain frequencies which are there in the optical fiber band.
ये हो गया ना, reject और pass. थोड़ा जोर से बोलो.
और जोर से. Hello.
हाँ, जोर से बोलो, मुझे नहीं सुना रही.
Okay, ma'am. अभी आ रहा है आवाज?
हाँ, अभी आ रहा है.
मैम मेरा तो यही था पॉइंट, रिजेक्ट और पास.
Okay, reject or pass. Okay, so उसको 2 पॉइंट दे देते हैं, 2 बार, 2%. Yes, continue.
Non-reciprocal.
हाँ, non-reciprocal. Okay. Then
मैम सिलेक्टिव और शार्प सेम रहेगा ना?
selective or sharp. What do you think? When I talk about the sharp, it is talking about the attenuation slope. This is something I am adding. Sharp means the pass band का जो slope है, that attenuation slope, it has to be sharp, ideally 90 degree. अभी हम filter design करते हैं ना, first order, second order, third order. So that slope, ideally we try to reach 90 degrees. So that is sharp. Selective can
minimize reflections.
Minimize reflection. Then yes, Jolly, some answers from your side. Jolly. Aniket, yes, I think you got full marks, no? In exam. Some answers from your side. Characteristic of filters. Yes. Aishwarya, any answers? Nitesh. Yes.
Manufacturing cost, like low manufacturing cost should be low.
Low cost. Then Abhishek Tripathi, Raul, you should answer. Adriel,
Stable, reliable, and efficient.
please write all these points because I might have less points in my slides. That's why I'm writing it out.
Ma'am, lossless can be considered as efficient only.
You have to specify in that. Please write down these keywords. That's why I'm typing it out. Characteristic of filters used in fiber optics. As I have already mentioned, it is a theoretical. This section is entirely theoretical. So all these are valid points. That's why I'm writing it out. I might have less points in my slides. Anybody wants to add anything or sufficient? Okay, so then let us continue with my slide. I hope you have written these points, all of you. Please have the
Yes,
habit
ma'am.
of writing. Yes. Okay, so see what points are there in my slides. Good optical filter should have low insertion loss. Okay, the filter itself should add less loss, low insertion loss. Okay, the loss should be independent of the state of polarization. These are the some words. See, whatever points you said were the general things. Now, since we have studied the polarizations and all, insertion loss, okay. So that's why I told you to write all those points, and these will be the additional points that you will write. So good optical filters should have low insertion loss. The loss should be independent of the state of polarization of the input signal. The passband, you talked about the passband. Okay, it should have a sharp, selective. Okay, that is good. But when I'm talking about optical filters, it should be also insensitive to the variation in ambient temperature. Okay, so apart from sharp, selective, attenuation, slope, it should be good. We have to say that the passband of the filter should be insensitive to variation in ambient temperature. So that is one of the points. Okay, so the way you said your answer is right, to it add all these points. So agar suppose this question is asked for 10 marks, see, still we don't know what kind of exams you will have, but assuming that you will have a written exam or so. Okay, so these points 5 marks के लिए भी sufficient है. You can explain, elaborate these points and make it a 10 marks question. Now see, we have a WDM system, that is wavelength division multiplex system. We have many wavelengths. We have seen that, or we have been telling that a single fiber can carry multiple thousands of signals. Now that thousands of signal will be centered around, we are not using the first optical window, we are using the 1310 and 1550 nanometer optical window. Matlab mera center frequency will be 1550 or 1310, and I will have multiple wavelengths. Okay, it can be dense wavelength division multiplexing or coarse wavelength division multiplexing. Okay, so every wavelength is centered around 1550 suppose, but it will have lambda 1, lambda 2, lambda 3 and so on. Okay, एक ही wavelength तो सबको नहीं दे सकते. Every channel will have a different wavelength. Okay, so more and more filters are cascaded in WDM system. So when I cascade more filters, because I suppose have more number of channels, so more filters, because एक filter एक channel को pass करेगा, बाकी को reject करेगा. That is what we have seen. So what happens is the pass band becomes progressively narrower. The diagram has been shown over here. See, we want a broad pass band. Okay, so what happens is as we are cascading more filters, the pass band becomes narrower. So to ensure reasonably broad pass band at the end of cascade, the individual filter should have very flat pass band. So when we design or select a filter, individual filter should have very flat pass band. Okay, we have filters based on different kinds of pass band. That is, we have started studying from the subject of LIC. So why we want very fat pass band? So that it accommodates small changes in operating wavelength of the laser over time. Okay, so this is also one of the characteristic of filters that we have to ensure when we are selecting filters or designing filters in case of fiber optics. And this point already you have mentioned, it should be sharp. When I talk about sharp, I'm talking of this. यहाँ पे देखो ये पास बैंड ऐसा स्लोपी है, ideally it is this way, ऐसा straight line. Okay, that is my ideal characteristic. It should be a straight line like this. That is my ideal one. Okay, so the passband skirt should be sharp to reduce the amount of energy passed through from adjacent channel. One channel will come over here. So here you will have crosstalk. Okay, so in crosstalk the energy is wasted. So we want to reduce the problem of adjacent channel interference. So for that the passband skirt should be sharp to reduce this adjacent channel interference. So I have only these 5 points listed plus the points which were already listed by you. So that completes now this next topic is grating. I will continue with grating in the next class. It's because this grating will continue for almost 2 lectures, so you can understand how important this topic is. Not important necessarily, I'm talking in terms of an exam viewpoint. Okay, for concept viewpoint, okay, this grating is important. That way I mean grating, or otherwise it's like just as a